I got drawn in on sort of into the subject about what happens after the fire. I just want to share some experience with you.
I learn so much by talking to other people that I meet, and I make really long-standing connections.
Pouring water onto an EV in thermal runaway is like pouring water onto the roof of your house when your kitchen's on fire. Thank you, gentlemen.
Excellent, thank you. Third time that I am present in this conference. I'm very happy to be here. The original title months ago was latest research, but I'm going to be talking about battery fires. You already had two really good talks on battery fires, so you're going to have mentions of things that you have already been told, obviously. I'm going to be talking about battery fires. I've been very concerned about battery fires since the topic started maybe 20 years ago, 15 years ago. And today I am worried. I know I share this worry with some of you, some other people, in particular from the battery industry that are not worried, and I worry that they don't worry. So let's talk about this. I call it a shape-shifting problem, because in these 20 years that I've been looking into battery fires, every 3 years is something else. Always a battery at the core of the fire hazard, but it expresses itself in different ways, bigger, smaller, closer to us, farther from us, in our homes, in our transport systems. And I worry about this because there is this concept in fire engineering, which is related to what I call blind spots. So a blind spot, by definition, is something that we don't see. We should be seeing it because we care about safety. It's a new technology. I'm an engineer. I love innovation. I love new technology. But new technologies often, actually, come with unintended new hazards. They are not intended. The engineers never wanted this hazard to express itself. They never thought about it. But you know what? Actually, it happens. And because the hazard is not being addressed, because it is not being understood, because very often it's not being seen, then the problem starts to grow. And we don't have regulation. Regulation is the minimum level of safety. Not even the minimum level of safety can address, by definition, a new hazard. And then the technology starts to be adopted, it starts to grow, and instead of being a few customers, now we're talking about hundreds and thousands and millions of customers. I'm talking about battery fires, but this applies to many other technologies. Until suddenly we can see them. Not just see them in the news, not just see them because there are speakers talking about it. We even see them now in the statistics, the specific case of battery fires. I've been giving a similar talk like this for the last 10 years. And I can only say that we can see them in the statistics for the last 4 years, or 3 years. Before, I knew they were happening, but they were not even in the statistics. So now we know they are in the statistics. And now they are growing. So now we see them. But you know what? Now it's not a blind spot. Now it's the elephant in the room. Now, officially, the London Fire Brigade collects battery fires. It's one of the observations that you can do when they go to a fire. So now we know that battery fires are the fastest growing threat to the city. Not the number one cause of fires, no, it's not. Not the number one cause of fatalities, it's not. But it's the fastest growing in the sense that if things continue like this, the London Fire Brigade will be extremely busy just dealing with battery fires. And that's concerning. The shape-shifting hazard that I'm referring to has this specific shape today. This is the one that everybody is talking about. I know the fire brigades, London Fire Brigade, but fire brigades in general are very concerned about this. E-mobility, e-scooters, e-bikes, PF, EVs. It has all these names, right? Okay, that's what we are referring to. This is an infamous video. It was released during the pandemic, actually. We were all in lockdown when this happened. It was actually in Spanish. I'm from Spain, hence the accent. So I was I could hear what the people were saying in the park. And the owner said, I am very lucky. This didn't happen at home. And it is absolutely true. This was a e-bike. Nothing happened. If it happened in the middle of the lockdown in a park, but what if it happened in a home? Now, this was in the year 2020, I think it was. Now we all know, unfortunately, what happens when an e-bike and a scooter gets on fire. This is a infamous video as well. I'm doing like Professor Paul Christensen. Is he still around? He left. But no, he likes to put a lot of videos on, and people love it, so I'm going to put a lot of videos. This is a fire. The fire is happening. Fire is not a flame. Fires sometimes don't have a flame. That's a fire. And it's undergoing in front of us. And it's growing really fast, and it has a very big cloud of smoke, very toxic. And now this is going to even have a flame. You're going to see it now in no time. For most of you are more familiar than me with all types of fires. That is extremely fast developing fire. You know already what happens. The smoke detector over there, the evacuation time that we assume that we will have with our time to decide what to do, the ability that we have to compartmentalize the fire. This is not how we design buildings for. This is a different hazard. I'll explain it to you. One of the talks that I gave, like this topic, was actually in Vancouver. That summer I was in Vancouver, and I said to the fire brigade in Vancouver, can I give a talk? That is the summer where Vancouver, unfortunately, had, for the first time, that battery fires was the leading cause of fire death in the city. So the Vancouver city was very concerned that particular summer. This never happens, that you have a new hazard that it was not even talked about 2 years ago, and suddenly it was the leading cause of fire death. I think since then, it didn't go that bad. I mean, obviously, people are still dying, unfortunately, in Vancouver because of different fires. But Vancouver was in the news for that specific bad record. Not just e-bikes. No, I talk to Elon Musk a lot. Well, I talk to him. He doesn't talk to me. In his Twitter platform, right? He says this is not a problem because it happens. An engineer told him that it happens less frequent. It is true. We are very lucky that this new technology, e-cars, are actually the fires that happen. They are less frequent, but that is barely any comfort of what comes afterwards, because the ones that happen in different places, like inside our houses, where our garage, where we park our cars, or in a car park when they are parked, or actually that the hazard breaches all the layers of safety that we have from traditional fire protection. That's concerning. This is a video that I show you very often. This was 2019. It's a car park in China. That's an electric car. You can see the logo. And you don't know this, but that car is on fire. There is no flame, absolutely fine. You don't need a flame to have a fire. But that car is on fire. The battery in particular is on fire, but you don't see it. That's different. From outside, we don't see the battery inside. The battery knows that it's on fire, but it's not telling anyone. There is actually someone passing by. There is a smoke detector. I think this car park, very concerning, didn't have a sprinkler, very concerning. And by the time we can detect, we, visually, humans, can detect the fire, that's going to be in a few seconds. Now you can see something is happening here, right? Now the plume of the smoke will go to this level. Now we could detect it. Okay, well, you have 2 seconds to evacuate. No one designs a building or a car park or any facility to have 2 seconds for evacuation. So that type of fire, it is, just because of the speed, it is a different type of hazard, very concerning. It's not just cars. I don't know if you remember what happened to Boeing, 787, massive investment into a new aircraft, partially electrified, consume less energy, had these massive batteries in the back that were partially taking some of the energy from the engines, and they started to catch fire on the first week that they started to fly. So they had to ground a brand new airplane, and within a month, record time, they don't tell us how, they solved the problem. And they solved it because since then they didn't have any fires, right? But you can see that it was a horrific inauguration of a new technology. And this is a proof, if there was any doubt, that for these technologies, these really incredible new technologies, safety is an afterthought. So first what they do is the innovation and the market, and they sell it. And then, oh, oops, and now are fires. This is not just when the batteries have in the market and are being used by us. When the batteries are being manufactured and they have to be stored until they arrive to the market and to the people and to the applications, they are stored by the billion of them. The storage facilities get on fire. I believe someone from FN Global is here today. FN Global is very concerned about this. Not when you have one cell, but when you have billions of them, and one of them, out of several billions, catches fire and then the fire starts to spread, and the sprinkler cannot cope. The losses is big. Economic losses, in principle, these storage places, in principle, are easier to evacuate, so it's not a safety hazard, it's a property protection hazard. That's what I refer to FM Global. And not even when we stop using them, they stop catching fire. When we say, okay, the battery is over, I don't like it, it has degraded so much, so many cycles of charging and discharging that I don't want it, it's an old battery, it has different colors, now I throw it away. And then this is what most people are doing, we are throwing them away because that's what we have always been doing with most things. And now they are catching fire even in waste facilities. This is a campaign, a British campaign, I love the campaign, they stopped doing it and no one has replicated, I wish it comes back. They give it a name, they call them zombie fires. Because we thought that the battery was dead, and suddenly it came back alive. And because it's discovered as a fire suddenly in waste facilities. Waste facilities have always had fires, but suddenly the number of fires in waste facilities will multiply by 3, by 4, by 5, by 6, and growing in time. And then when they started to investigate, very, very often they were seeing a battery at the location of the initiation. So since birth of the technology, when they are manufactured and they are stored, through the whole use of the technology, and even when the end of life of the technology, we see fire, right? It is intrinsic to the technology. This is a table of the ones that you have seen in the news, of all the, unfortunately, if the slides are shared, you can read it then later on, but we have cell phones. You know that Nokia almost went bankrupt. You remember the Samsung Galaxy? Does anyone of you own a Samsung Galaxy? Check the year of manufacturing. Laptops, IBM had a massive issue with laptops catching fire, it was really bad. Electric vehicles, all of them, every single manufacturer had more or less problems with fires. They had to resolve it, and very often they don't tell each other how they resolve it, so the other ones had to start from scratch. Aerospace, hoverboards, who remembers the hoverboard, the Christmas concern? This was way before electric scooters or e-bikes. Marine has been referring to this. Not just that the ship is actually powered by batteries, very large batteries, but also that the ship might actually be carrying electric vehicles in the middle of the sea and might catch fire. And the one that probably is in the mind of many of you today, it is in my mind, the stationary energy storage inside buildings, BESS, not building storage, building energy storage systems. I'm very concerned. I've been doing fire engineering for many years. Buildings in the UK are very safe. Definitely as an average are very safe. Bringing this into the buildings, I don't know. I don't know how it's going to be done. But it has to be done carefully. It has to be done understanding the hazard. It has to be done realizing that this hazard is different. So the solution, unfortunately, will have to be different. The solutions that are in the regulations, which is the minimum level of safety, they were created over many years to address all the types of fires, not this type of fires. And why is this? Because I do believe that lithium-ion batteries, once upon a time, was a blind spot. Now it's an elephant in the room. I do believe so. I've been saying this for a very long time. Now I have the data to show it. It's not that the battery is, the battery is flammable. We are used to deal with flammability. Your chairs are flammable. There is just a level of flammability that is controlled to the point that actually doesn't create a hazard in this room. So we are used to deal with flammables, the textiles. Our buildings, our lives are full of flammable elements. We can live with that as long as they're not extremely flammable and that we keep them away from ignition sources. The problem with the battery is flammable and it has an ignition device attached to it. It's the two things, it's an ignition and flammability. Typically, fire engineering says separate ignition from the fuel. Well, in the battery, you can't. It is literally impossible to separate the two of them. They come together, right? And they come together and they come in very different sizes. They come from very small to very large. And they age because you buy them brand new. And maybe the manufacturer that you bought it from, spending more money into this, is a really reputable manufacturer that doesn't want, it doesn't have the standards to comply with, but they don't want their product to be in the news. And then it's very good. But they will age in the sense that 3 years after being used, it's not the pristine system that is amazing that you bought. It has been aged, it has degraded. We don't know in which ways, but we know that whenever we look into this, an older battery is never safer than the new one. We've never seen a technology in battery size that actually, as it degrades, it becomes safer. We haven't seen that yet. Right? So we are concerned about this. Obviously, fire engineers, and the room knows this by heart, we are dealing with so many fire hazards we're dealing with. And what do we do, without going into the details, is we call for multiple layers of protection. This is the fire, this is the hazard, and over there is people, property, and the environment, and we want to protect it. And what do we put? We put as many things in the middle as possible, literally. Do we put just one? No, we don't put one. Why? Because nothing that has been done by humans is perfect. It can be better or worse, but nothing is perfect. Therefore, all layers have vulnerabilities or issues, but known or unknown. We put many because then the holes will not align. Right? The holes are the imperfections of this layer. This is what they call the Swiss cheese approach. Chemical engineers use this reference a lot. And that's why we need to put different things in between. It gives us redundancy, it gives us, at the end, a higher level of protection. So there are many layers in between. Each of you are in different sectors of fire engineering, so you will recognize, oh, the best layer is this one, the one that you work on, obviously. So because I don't work in a specific layer, I work on all of them, I see beauty in seeing them all together. And following the way Professor Dougal Drysdale in Edinburgh teaches this, I recognize that there are at least 6. You can actually put them all together. The first one, single most important one, is prevention. It's not to have a fire to begin with, which means the fuel is allowed to be, the element is allowed to be flammable, but not too high flammability. It has to pass a standard for a maximum member flammability, and it has to be separated from the ignition sources. This room has ignition sources, and it has flammable materials that are just not together. And when they're together, the ignition source is not too powerful, and the material is not too flammable. Otherwise, if you have a very flammable element and a very unreliable possible ignition source, you have actually a hazard. If there has been a fire because it has been a breach, well, I'll do it from here. See where? No. Okay, well, you can count. Second layer is detection. We want to know that a fire is happening. The first one has been breached, prevention. Happens very often, right? Fire brigade is only called when fire brigade is often very cold when there is no fire. But the one that requires a big action, we want to detect because we know something is happening, so we can take the next level of decision. So detection is absolutely essential. If there is no detection, all the layers now are losing the race against the fire. If there is early detection, there is hope for some of the layers. The first thing that we do in fire engineering is we evacuate the building. Absolutely essential. We evacuate the room of origin for sure. We will probably evacuate the story of origin. We will not evacuate maybe the whole building or the whole neighborhood, but all these layers of possible evacuation are important. And then what do? We also play compartmentation. This is a beautiful reliant historically of the UK, compartmentation. That's why we have so many doors with the blue sign. When foreigners come to the country, some of them are here, they think, guys, how many doors do you have? There are a lot of doors in the UK. There are fire doors because we believe in compartmentation, which is a fire has happened in the room of origin. We don't want the smoke or the flames to go to another compartment. We want to contain it in the room of origin. Every country believes in compartmentation. The UK likes it a lot. And actually, the standards and the philosophy of design in the UK relies a lot on compartmentation. The Americans do this less, for example. Equally safe environment in the US, similar materials, but they don't rely so many on compartmentation in fire doors. They rely more on the next layer of protection, suppression. You can have early suppression, that would be the sprinklers, which we do have today. We have sprinklers today. It's unusual in the UK to have sprinklers in the room, so I'm not used to be able to refer to them. In the US, you will have sprinklers everywhere. The US relies a lot on suppression, on early suppression. The UK, less. The UK relies more on compartmentation. The two of them are equally safe, definitely for life safety. And for property protection, we can discuss it. And then the last layer, the one that is called chronologically the last, but it's also quite important, is structural resistance, that the building does not collapse when there is people inside or fire brigade is inside. If the building is completely evacuated and it can be proved, and there is no fire brigade that has gone inside, it's debatable with authorities and the insurance if it's okay for the building to collapse. It's actually illegal for the building to collapse if there is absolutely no one inside. But it's obviously very concerning to see a building collapsing and the engineer saying it complies with regulations, job done. And these are the layers for protection. All of them, literally all of them, are challenged by the new hazard of battery fires. Prevention, the initiation route and the fact that the combustible and the ignition source are together and they are aging and they are coming from different bad sources of the technology creates that we cannot prevent them the way we prevent in the other ones. Detection, it happens so fast. By the time we detect them, even a kit does better job than a small detector detecting a battery fire. It's so fast and so obvious when it has happened so sudden that actually our detection layer is breached. Evacuation, because the detection happens too late, the evacuation now already has to catch up, is losing the race against the fire. Compartmentation, you've seen what happens. Battery fires, not always, but very often produce jets. It breaches the pouch, the cell, the shell of the cell. It breaches it in a particular location, not everywhere, and that creates a jet fire. This jet fire is about 5 times longer than the battery. So if it's a small battery, this jet fire can actually reach here. But if the battery is like this, then it actually proportionally starts to go a jet fire that can actually go past the balcony of this building. So this is a breach of compartmentation because the jet impinging specifically on that very location of the fire door or the wall, it is not the same as gentle furnace heating up slowly for 16 minutes. This is a completely different scenario. Chemical engineers know about this because they have to protect their pipes against jet fires, and jet fire is the single most difficult scenario to prove resistance against. So jet fires are in batteries. And suppression, we still don't know how to suppress battery fires. If any of you do, you will be millionaire if it's true. Just saying it is not enough. You actually have to actually do it and prove it scientifically, right? Because we don't know how to suppress it. We can mitigate it. We can reduce the heat release rate. We can manage the smoke. We can reduce the flammability of the smoke that is being produced. We give more time for the fire brigade. We can do many things with a lot of water, namely. We still don't know how to, we is collective human knowledge. We humans, we still don't know how to suppress them. And the structural response is because everything happens fast, but for a long time, because these fires can happen for a long time, and it can concentrate all the heat release rate in a specific direction as opposed to have it all over the ceiling. It creates the vulnerabilities in the structure. Imagine that it's a jet fire of a big battery specifically on the middle of the column, just one column receiving the whole heat release rate. So Elon Musk says, don't worry because the electric fires happen less frequent. And then, as Professor Sixtensen said, and the heat release rate peak is the same. Yeah, but it's not the same to distribute it over the course of 20 meters square than to concentrate in a jet fire on a very specific vulnerable structural element. It is a challenge. It's going to happen. Probability is low, but it is a challenge, and the structural engineers and fire engineers need to start thinking about this. So it challenges all the layers that I mentioned. The one that I haven't mentioned, 2 of them, one is toxicity, the smoke that is coming out from a battery fire. I insist that it doesn't have to have a flame to be called a fire. It is just, what is happening inside the battery is already a fire. So the smoke is very, very toxic to the level of toxicity that chemists and toxicologists are not used to being asked to assess it. So actually it's still a pending topic to quantify that toxicity. When they look into specific elements that they see in the smoke, they always raise alarms. The latest one is fluorides. So because the chemistry is very advanced and it's a very aggressive chemistry, it produces molecules that no one before had bothered to study what would happen if it's breath or if it's actually deposited on our skin. And the latest one, Professor Christensen replied to, is that the smoke that they produce, these fires, it actually is as most smoke in the world, but this one as well is flammable. It can actually ignite and lead to a deflagration or a vapor cloud explosion. This is because of net zero. I believe in net zero, I believe in electrification, I believe in innovation, but it should not be at the cost of safety. So this new ethos that is very important for the UK and for the rest of the world of net zero is to be done, but the fire hazard of electric batteries has to be addressed, and is now an elephant in the room of net zero. And very few people want to talk about it. And I don't know if you've gone to their meetings. but they don't call it fire. I don't know if you noticed, this is when a battery is on fire, they don't call it fire. They say it's a thermal event. And I'm an expert in heat transfer. I said thermal event is the sun rising up. Thermal event is my coffee in the morning. Thermal event is the engine brakes heating up. Thermal event, there's another name for fire, it's called fire. No, they don't say fire, right? I think it's psychologically, they don't do it on purpose. They say it's so bad what is happening with this elephant that we cannot call it by that name. It's a forbidden name, right? We don't mention that name. They don't mention smoke. They mention flame, not very often, but they say mention flame. They don't say ignition, they say thermal runaway, right? All the names that you fire engineers, fire brigades, and fire industry use, all of them have been removed. We are being transplanted into a parallel universe where none of our names and words actually exist. Very concerning. So this is not something relatively new. When I was in 2016, that was a long time ago, I was asked by NFPA to do a survey of what was in the mind of the fire experts in the world. So I had the joy of interviewing 100 of them. So very quickly I will tell you, I said, what is it that is worrying you about things that might happen? And they said, new buildings, right? They said timber buildings. This was 2016. They say building facades. This was the year before Grenfell. And they say number 4, battery fires. So it was the number 4 concern already 10 years ago out of a list of 30. So we knew it was coming. We just could not we didn't have the high level evidence because it was not being captured yet in the statistics, right? So I'll go as quickly at this. It is not just all bad news, and it's not like all cowboys selling batteries to the wall. In reality, these companies slowly and as an afterthought, they're actually at a glacial pace developing technologies, and their batteries are finally getting better and safer, so especially for the good manufacturers. The bad manufacturers, you don't even have a name for them because they change name like every 6 months. But we have now technologies in prevention. For example, the electrolyte. I'm highlighting in blue the good stories. The electrolyte used to be flammable. Electrolyte is a liquid that is actually very important in the battery. It used to be flammable. I don't know who had the idea of putting an electrolyte that was flammable, but now there are electrolytes that are much less flammable or non-flammable. The container now is sealed. It's not just a plastic. For example, what Boeing did is they create a steel box, and the battery goes inside the steel box. So if it ignites, it's fine. It stays inside the box, and the airplane is safe. So that's a containment technology. Detection, they've been using what is called these little computers that go inside batteries. It's called battery management systems. They look for anomalies. The voltage is doing something funny. That is because a thermal runaway is happening, it's ignition taking place. And also fire suppression. There is a new method of suppressing fires. It's called by flooding. It's a container. I think some fire brigades around the world have this. A little container is full of water, and they put the massive battery with the car or something else inside. They flood it, and if it's not suppressed, at least with the water, it will remove all the heat, and at least it can take it to a different place away from the harm of people. So with this, I just want to finish. And I've been very frustrated of why safety is an afterthought for such a cool, exciting, and wealthy technology, right? Batteries is not a technology that is about to be bankrupt. It's actually the next future in business. And until I saw this slide is the cost of batteries. Batteries are expensive, obviously, but also there is a massive market. So if you have a better technology, you can sell more. Most of the price goes into the construction and the research of the cathode. So the cathode sets your battery. It's half of the cost of your battery. Not the manufacturing cost, but also the development cost. At the bottom, you have the electrolyte, you have the anode, and you have the casing at the bottom. Here, like, who cares about this? We care about this. This is the number one way to address battery fires. Deal with the electrolyte, deal with the anode, and deal with the sealing, with the casing. Why is it not done? Because you will not displace the competitors by doing this. So a safer battery doesn't gain market because it doesn't sell more. And that is the sad truth of the phenomenon, that although we are in this room very concerned about safety, outside this room they feel so safe that they're not concerned about safety, or at least not yet. So with this I finish. Battery fires, shape-shifting hazard used to be a blind spot, now it's an elephant in the room. That there are improvements at a glacial step. Batteries now are slightly less concerning than they used to be, and hopefully this will keep growing this trend, but much faster. That we need to work on suppression, we need to work on detection, we need to work not just at the cell level, but at the cells that are bigger. And that for me, it is uncontroversial that if we understand the hazard, we can develop safer technologies. And for me, a safer technology is a better technology. So I'm telling to the industry, although I know they're not here today, if your batteries are safer and you can prove it scientifically with evidence, you have a better product to sell to your customers. Thank you very much.
Thank you.